this all happened to this little board anyway?
Someone spooged in it.
Huh?
Someone spooged in it. Spooge. You want me to show you? That's what I thought.
Yeah.
Hey everybody, how's it going? So today, it's time for yet another episode of Broken MacBook Board Repair. Let's take a look at this MacBook, which is an A1466 Macbook Air. See if we can figure out what's wrong with it and make this board work again. First thing that we're going to do is unplug the battery. We're going to turn on our power supply and see how many amps this MacBook takes, because that's going to tell us what's wrong with it. Alright, get the power supply software on the screen, get that beautiful Paul Daniels multimeter software on the screen, and turn this thing on. 12 to 24 milliamps, which means this is probably missing PM Sleep S4L, the most annoying board repair there is. Yay. Is PP bus present? PP bus is 4.2 volts on that side and 4.2 volts here. So it looks like we're actually missing our PP bus. This is not going to be PM Sleep S4L missing. This is going to be PP bus missing. I've never experienced that on an Air at 24 milliamps. That's very strange. So let's get the board out of the case and see if we can figure out what's going on. I'm going to guess that this machine has liquid damage on the ISL 6259 chip. And as you can see, we have corrosion in just the area that I anticipated, the ISL 6259 area. So now what I'd like to do is see if that polarizer filter that I got for my microscope camera makes a difference. A lot of you have been suggesting that I get a polarizer filter so that when I solder and there's flux, the reflections are a little less annoying, and also when I turn up the lights so you can see the detail, you don't see all the annoying reflections off the components. This thing was about $120 after tax at Adorama. To be honest, I kind of just wanted an excuse to go to Adorama so that I could take a look at the Sony FX7 and FX9, which I did for about half an hour. I was able to leave Adorama without purchasing a new camera that is way outside of my budget. But I just wanted an excuse to kind of go and play with look at my toy. So let's see what this looks like under the microscope, and let's see if we can get this thing to work again. So I'm going to turn on the microscope light. Now the thing is, in the past, a polarizer filter wouldn't have really worked because you need to have a lot of light, because it kind of turns down your light. However, I have since overclocked my light. I have overclocked my light so that, yeah, look at that. Alright, so hopefully the detail will be better now. Let me just lock the microscope in place so that it doesn't shake as much. There we go. Is that a nice quality image? Hopefully that looks better than it did before. Thank you everybody for your suggestions here for the polarizer filter. I really appreciate it. If the video looks better now than it used to, well, every one of you who suggested that I get this polarizer filter, give yourself a little pat in the back, because this superior video is because of you. I really do like excuses to spend money at Adorama and B&H. It's an addiction. Now these, I imagine, are the current sense resistors, and they look toasted. This is the 48 millimeter one, Criminal Minded. So the whole concept is that when I use flux and solder and all that, there's or alcohol or anything, there's usually a lot of reflections, and there's also, when I turn the light up, reflections off of the metal from the solder pads themselves. And that with the polarizing filter, you should see less of that. That's the idea. And let's see if that's how it works out in practice. So let's add some flux here. See if I can kind of scrape away and get those points back to their beautiful luster. Now the pads for the resistor themselves seem fine. It's the pathway between the resistor and the chip that seems broken. So you see this? You see how there's like this over here? Yeah, I'm gonna up. Also, I can up the light. It's bright. Nope, nope, nope. Light doesn't like more than 14 volts. Alright. There we go. Alright, so you can still have all the flux there, but still get a good picture when the light is high. Awesome. So here you can see that the probe point is kind of broken. Now, I'm not trying to solder on top of it. What I'm trying to do is scrape away the corrosion. Scrape away the corrosion. And then solder over. Same thing here. Just mild scraping at first. And there I can't. So here I may be able to get away without a jumper. Probably not. Here I definitely need a jumper. So we're going to install a couple of jumpers over here. Now our main issue appears to be that one of the current sense resistors is not connecting to the ISL6259. So there is a current sense resistor on the other side of the board, and the way this works is the current sense resistor is going to have a really small drop in voltage across it, and that small drop in voltage across the current sense resistor is going to let our ISL6259 know how much current the system is using. The larger the voltage drop across the resistor, the more current the system is using. The less voltage drop across the resistor, the less current that the system is using. Now, on each end of the current sense resistor, on the beginning and the end of it, there is yet another resistor, and its purpose is to go to the ISL6259 from the current sense resistor, so that the ISL6259 can see what's happening on each side of the current sense resistor. And what you see are this is the path that the ISL6259 has to that current sense resistor, and it's completely destroyed. So the ISL6259 is going to see 8 volts on one side and 0 on the other, and it's going to think, whoa, that's a really big difference. So that must mean the system's taking a million bazillion amps, and it's going to turn off the power rail because it's trying to protect itself. I could show you that in the schematic later. And what I'm going to do is I'm going to run this little jumper wire over here. Now, anything you see there that doesn't look like it's perfectly set in place, you'll see when I use the hot air that it will be perfectly set in place. I don't really care if everything isn't perfectly set in place. What I care about is that the proper amount of flux is there, so that when I use the hot air, it'll kind of move itself into place. And also, if you see any solder joints where there's a little bit of that Hershey's Kiss effect on it, that's going to be because there was not enough flux used in the soldering process, which is also fixed by me putting flux there. TLDR, you really can never use enough flux, and anybody who tells you otherwise is evil. No, that'll flow. I don't feel like turning the board around. So, but the hot tweezers are going to make all that shit flow into place. You'll see. It's going to look really nice. More flux because more better, right? We got some more work to do here. Let's just flow all this stuff into place. Yeah, you see how that all flows into place? So that's the secret, because a lot of people don't understand how with unsteady hands I can do stuff so that it looks like it's factory. And the way I get work done, even though I have very unsteady hands, is that little trick. The surface tension is going to pull everything into place to exactly where it's supposed to go. So it's not like I'm sitting there and perfectly aligning the QFN of the BGA or the resistor. I put the thing there like a total idiot who has no control over his hands, and then I flux and wait. The flux really makes me look a lot smarter than I am. I'm much more skillful. You know, I'm really defrauding all these people into thinking I have a clue what I'm doing, and I don't. It's the flux. Alright, this over here also looks really bad. I gotta see if this that corroded probe point goes to anywhere on the other side of the board or not. And this one as well. I may wind up running a wire just because I don't really trust that long term. There we go. So what I want to do is I want to scrape the corrosion without scraping the copper, which is a hard thing. Too little scraping, you won't get the corrosion. Too much scraping, you'll scrape the copper. And then once I get to the copper, cover it in solder so that it doesn't go bad over time. This is the point at which it would make sense to just turn the board around. Stop being so stubborn. This area doesn't look too terrible, but it does need touch-up. See all that red stuff? That's the board bleeding. I don't want the board to bleed. Hello. We'll do this. You can see this probe point is shit too. I can't trust that that's connected to whatever it's supposed to be on the other side of the board. Ah. Oh well. Roar. Just knocked everything off the board. I knocked everything off the board and the customer's watching on stream. Oh well. Oh, this is a good day. Erica, the person who sent this in is watching as I knock all this shit off of their board.
Okay. I'm gonna fix it, so.
Yep.
Hey, did you drop the tweezers over there? Is that
Those are garbage junk tweezers that are me. Absolute shit condition. No need to get nervous when you know what you're doing. I can fix that. Easy breezy. Cover girl. Easy breezy, beautiful cover girl. Get off the tweezer, you fuck. This shit is so small. That's the thing. Like, if you've, I'll feel like I'm getting it not 100% perfect, and then I just have this feeling like I have to sneeze, and without even sneezing, just feeling like I may have to sneeze, and everything just goes running off of the board. And I realize that I'm working with microscopic crap. It really puts things in perspective. That the tiniest fucked up hand movement just makes everything on the board go poof and disappear. That should be good to go.
Ooh. How's it looking?
Not bad.
Good.
So remember how I said that this probe point over here, I wasn't sure if this was going to the other side of the board properly? And if you look at it, this kind of, see this? It's like kind of half on there. That's part of the battery current sensing circuit. So to go over current sensing here before I get finished, if you take a look, you have two current sense circuits, one for the charger, one for the battery, because the computer wants to know how much current the charger is using and also wants to know how much current the battery is using. So here's where the power comes in from the charger. It goes to this transistor. What this transistor does is it essentially makes sure that if the charger is not plugged into the wall, the battery does not go back through the system and try to charge the charger. Make sure that things only go one way. It goes through there, and then it goes to this current sense resistor. This is a resistor that is in the circuit path of the charger going to the computer. So it's in the stream. So imagine that you wanted to know how fast the stream was going in a river. You can't simply tell by looking at the water, if you're far away, how fast it's going. You'd have to put your hands in the stream and feel how much pressure it's pushing with. And then you'd have an idea of how strong the current is. And the same is true here. The ISL 6259 can't tell how much current is going through the charger just by being next to it. So what it does is if I wanted to know, if I'm on top of a mountain and I want to know how much water is going to the stream, I could ask my friend, hey, can you put your hand in the water and let me know? And give me a phone call, tell me how hard it is. Over here, the ISL 6259 has his friend, R7120, put his hand in the water. And then R7120 calls U7100 on resistor R7121 and R7122. So over here, let's say you have 18 volts for a charger, right? And then you have 17 over here. It'll think, wow, that's a huge difference. That must be using a lot of amperage. Let me shut the system down. Whereas if you have 18 volts here and 17.9999999 volts here, it thinks, all right, cool, this is just being a normal MacBook, not taking too much. And since there's going to be a voltage drop from this side to this side, you have a resistor going between the ISL 6259 at the beginning of the resistor and the ISL 6259 and the ends of the resistor. Now, if this resistor is burned or this pathway is blown, then you're going to have 18 volts here. The ISL will see 18 volts here, but it'll see 0 volts there because this path is blown. And it'll think there's a 18 volt difference between here and here, which means when it does its little internal calculation, it's going to think the system is using 1 bazillion, gazillion, trizillion amps, and that's no good. And it turns it off. Same is true for the battery. You have a current sense resistor over here. So here you have to/from battery. And before it gets to the system, the first thing it gets to, current sense resistor. Before the resistor and after the resistor, each one, you have a path going to the ISL 6259, the charging chip. Now, one of the things I do, if I want to see if this path is working, I'm not going to measure from here to here, and 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 here to here, because that's a big fucking waste of my time. What I do is I add up the resistances of everything in the circuit, and then I measure between here and here. If this is a loop, between 27 and 28, I should just get, 10 ohms plus 0.02 ohms plus 10 ohms. And back again. Let's see if that's what I get. I'm going to turn on Paul Daniels' amazing multimeter software and see what I measure. So for charger current sensing, I have to turn to ohms mode. For charger current sensing, 20, the path is not broken. For battery current sensing, 31.5 million ohms. The path is broken. So even if this turns on via charger, it's not going to be able to charge the battery because it's going to think it's using too much current. Now, I'm going to guess that the path is blown between here and the other side of the board. So let's see where that connects. Let's go to the schematic on the board view. Where do you connect to? Well, you go through U5600. I wonder if I can just kind of run a wire between here and there and get away with it. That would actually be much easier. Let's see. Turn on the fume extractor. If not, then I have to run a wire to the other side of the board, which would suck. And the board looks like a freaking banjo.
Don't worry, it's not like the person who has this computer is going to see it, right?
Yeah, the person who owns this is never going to see what a botch job this is anyway, so it doesn't really matter.
Yeah.
It's not like he's like watching the video in 1080p 60 in the chat.
Yeah.
Or something like that.
Probably went to the bathroom or something.
Probably went to the bathroom or something. He's never going to see this. I'm probably giving the guy a heart attack. Oh, man.
Crap. I think he came back from the bathroom if he was in the bathroom.
I like to run the wire in the same direction of the leg. It's a little OCD thing of mine. It shouldn't matter, but...
Scott says let Erica fix it. Scott, bad things will happen if I go ahead and touch that board right now. It's a very bad thing.
I believe in Erica. I believe in Erica more than Erica believes in Erica.
I believe in myself too, but I just don't believe it. I should be working on this board.
I'd let you work on it if you said if you wanted to work on this right now with the customer watching, I would say go for it. Mm-hmm.
How many caps and resistors do you want to have to move back into place or replace?
I'm sure he won't mind. Right, guy?
It's gonna look like alphabet soup.
Let's have a vote in the chat. How many people think that I should have Erica try to work on Linux Guru Gamer's board? Right here. What do we say?
No. There's a few rational people over here. No. Oh, crap.
Yeah, the yeses are outdoing the no's. Actually, this wire I just bent. Shit, yeah.
You bent it.
This wire is more bent. This wire is more crooked than Erica's strategy for winning plush toys.
Man, if I did a board repair video, I think I'm gonna get downloaded so hard. People are gonna angrily email you and say, Lewis,
that's
I
unprofessional.
subscribe to see you, not anyone else, just you.
They wouldn't say that if you fixed the board.
Jim says we want Oriole to work on it. Jim, I'm still trying to get Oriole to make it to the litter box.
Alright, so you got a kind of half-ass solder joint there. I can route that wire a little later. Let's see if that changes the resistance. We're looking for... So the two resistors there, I believe, is a 0 ohm and a 2.2 ohm resistor. Yeah, 0 ohm plus 2.2 ohm plus 0.01. So we're looking for 2.201 ohms. Is what I should get here, if this is going the right way. Fuck you, 11 million. You piece of shit. Let's see. Wait a second. Did I just put a bad resistor on the freaking board? Oh my god.
Do you want a cookie?
No, I want a 0 ohm and 2.2 ohm 0201 resistor. Wow, the resistor I took off my freaking donor board. Oh, wow. I got trolled. The resistor on the damn donor board is no good. Piece of shit. That's the first time that's happened to me. Current sense. Okay.
First time for everything.
Well, the thing is, I save time using donor boards instead of the new resistors book, and people have always asked, well, why do you do that? Because it saves time. It's still, I mean, the amount of time I've saved over the past 7 years is still beats. It still makes up for this. Although this was a good troll. That resistor is going to be upside down just because.
What's the chances of the person owning this computer saying that you put a dud resistor?
He'll be fine. He watches the channel. He knew what he was getting into. I also got to rip his JTAG off. That resistor is upside down, just like Australia.
You didn't go on a bathroom break yet.
Okay. We want to get you to the probe point and the resistor at the same time. Is this an Australian resistor? This resistor is from the land of Paul.
Wow, look at Paul Daniels. He's telling you to hurry up. Paul, we should send you some cookies over there. Or Cinnabons.
I don't know if they have that cookies in Australia. They have eucalyptus leaves for the koala bears. That gunk over there is going to get cleaned out by the ultrasonic. Also, that was... Let's see. What do we have now? Piece of trolling shitboard. So... Bam! Bada bing. Close enough. Now, next up. This little piece of shit. I don't trust the way this looks. I saw a little bit of red under there. And I was right. Yep, there was a little bit of red.
What's red?
Rusting, kind of.
Oh, corrosion.
Yeah, it's not too terrible, but I don't want to leave it there. We already made this an Australian board.
What a generous amount.
Proper amount of flux there, Coco.
Night jumps, what is your definition of quick? It's all subjective.
This here is superficial. Superficial, but still triggering me. Superficial, but still triggering me. Alright. Now we gotta make sure this... I'm pretty sure this doesn't go to any... This is just a measurement point. That doesn't actually go anywhere else on the board. That's... Oh yeah, that doesn't go anywhere else on the board. Or does it? Yeah, it does. Son's a bitch. Let's charge your phase. Someone spooged in it.
Huh?
Someone spooged in it. Spooge.
What's
You want me to show you?
Uh,
That's what I thought.
yeah. Okay. Oh.
I want to get to that nub under there.
Lewis is mining for copper.
Let's make sure that's not ground in there. Because if I dug to ground, then this is useless, and I gotta start over at the other side of the board. You're not grounds. Now, are you grounds? Ew. Nope. Wait. What the fuck is that? Yeah, not ground. Okay. Keep digging. Are you using a wire brush? I'm using a knife. Using a knife and scraping the shit out of it. Moment, I'm going to take a solder ball probably and toss it in there and use the hot air to make myself a solder pad to run my jumper wire to. Ooh, yay! I just made a solder pad. Look at that. I made a friend.
You made a friend. It's like Olaf.
Come on, get in there.
Hey, why do you think Apple doesn't conform or coat their boards?
Why would they do something that would save their users money? Like, why? Alright, that's good. All I wanted was a bump, and I got a bump. That's all I needed. I'm not actually going to solder to it. I'm going to tin a wire. I'm going to try to... maybe I will try soldering. Instead of hot airing it in. Crest Ultrasonics was my customer for a year about 10 years ago. How hard was it to get them to call you back? I'm curious. Fucking motherfucker.
Language.
Yeah. I can't tug on the wire because that probe point is so weak I'll break it. I'll rip the probe point off the board. It's not like I can... There's nothing structurally holding that in. So I have to have the wire pushed into the board. There we go. So now I can rip this off here.
Oh.
Now I can rip it off the capacitor. The capacitor is held on by a nice beefy pad. I'm hot airing it because I want the wire to flow into place. That thing that it's soldered to, that little point, that's barely a solder pin. That barely exists. So it needs to be in the exact right spot. Now this thing over here, I don't care that this looks fucked up. It doesn't matter at all, because that's just for testing. So see how the chip, there's a trace that comes out of the chip and then it goes here, and then that's just a probe point for measuring. That can look fucked up and who gives a shit. This matters because this is where it's going to another part of the machine. This is where charger phase on another part of the board is coming into the chip, and that can't be messed up or else there's nothing going to the chip. So that fixes that area. Now I'm just going to rapid cool the board using our patent pending rapid cool technology. Let's do this. Bing bada boom. The board loves it. The board loves rapid cool technology. What do you guys think? Fan spin? After this I got to get a little bit of business administration work done. Eat some food. Alright. I think the board's gotten itself cooled off enough. MacBook doesn't deserve to be any colder than that. Come on, little MacBook. Oh wow, it didn't fall. Strange. Alright, let's see what we get. Come on, 500 milliamps and booting. 500 milliamps and booting. Yes! Fan spin! This is a 3437, so it's going to turn on, off, on, off, on, off, on. Don't ask me why they all do that. So you do an RTC reset, not sure why. That's not a glitch, that's just it being a MacBook. So I do this. I do this. Oh, well, why is Paul Daniels' software not showing that I switched over to volts? There we go. Alright, so as you can see, we get 8.5 volts on PPBush D3 Hot out of the 4 volts we got before. 500 milliamps, which means the CPU's on, brain's working, and the fan is spinning, which, as you know, that's pretty much testing done here. There's not much more else to it when it comes to Rossmann repair quality control. So what was going on here is that the traces were corroded for several lines, the current sense traces that I explained to you. In addition to that, we also had another corroded probe point between, if you look on the board right over here, so charger phase goes to this capacitor. This capacitor sits between charger phase and charger boot, but charger phase is going to be this section right here. Charger phase is coming around here. Right after the transistor, so this is the way PPBush G3 Hot's going to work. You have the charger, which is 18 volts coming out up here. This allows it to come through. Then this is going to switch on and off. So you're going to get 18, 0, 18, 0, 18, 0. And eventually it's going to average itself out to 8.58 volts. This chip is the chip that decides when this transistor, which is essentially a switch, turns on and off. So think of it like a light switch that's going really, really fast. Once it goes through the coil and as these smoothing capacitors to ground, instead of having 18, 0, 18, 0, you get a nice smooth 8.5 volts. Before the coil, but after the transistor, there's this point that goes to the ISL 6259, just so we can get an idea. It needs to remember what I've said. The chip needs to see what it's doing. If it's a DC to DC boost circuit for a backlight circuit, you have the feedback trace, and over here, you have charger phase. The chip needs to know what it is doing. It needs to know, am I switching too fast or switching too slow, so that it can adjust itself. Same thing as if you're driving. If you're driving and you're in a car, you can tell because you can see the speedometer, how fast you're going. If somebody just covers your eyes, you can't see the road or the speedometer, what do? You hit the brakes. You don't know how fast you're going. You don't know what's in front of you. So same thing is going to happen here. It needs to have this. And this was broken, in addition to the current sense traces that were broken before being broken. So we ran a bunch of wire to everything. I think that's 44 or 46 gauge Remington magnet wire. You could find links to it down below in the description. And that's about it. This board now works. And as always, I hope you learned something. I'll see you in the next video. Thank you so much for watching and for being a part of what we do here. Bye.